Okay, so this is a video editorial for the LeetCode Weekly Contest 496. Like the contest, I felt like Q3 and Q4 was like decent. Q3 was really good in my opinion, like especially for Q3. Like you could see like four wrong submissions with 20 minutes penalty. It was like I had to think, like my initial thought was incorrect, but yeah. So I'll be going through the problems in order of their appearance, and I'll be showcasing the explanations. I'll be showcasing my solutions for the problems and explaining how and why I did that during the contest. And after my explanations, I'll also attach a live solve section where you could see how I approach the problems in the live contest scenario. Alright. So Q1 was it was a 4-pointer. Basically, if I had to simplify the problem statement, basically you are given a string with alphabets and numbers, and mirror is basically the opposite, like for the so basically, like if we, for defining the mirror, if we have this like from 0 to 9, 1, 2 and so on till 8, we'll take a mirror in the half, and then for 0 the mirror is 9, for 1 it's 8 and so on. And similarly for alphabets, we have A to Z, the mirror for A would be Z, for B it would be Y and so on. And since both the number of alphabets are even, 26, and the number of this, what do we call this, digits are even, which is 10, a mirror will always be different than the current element, right? So we had to, for every element in the string, we had to find the absolute difference between it and its mirror. So the implementation was straightforward. Basically, we make two frequency arrays, one for the characters, one for the digits, and if it's a character, then we increment it like this, else we increment it like this, and at the end we just iterate on both of those frequency arrays, and we do the operation which was defined to us and add it to a result. So this was fairly straightforward. Question 2 was interesting as well. Basically, we are given a integer n, and yeah, for question 1 the constraints were less than equal to 25, but since our solution is O of n, this will run, right? Since we are just one scan for incrementing the frequency, and then O of 26 plus O of 10 for this part. So Q2 we had basically an integer n, and we had to find the number of n's such that a number of integer x less than equal to n such that we have at least two a comma b, two distinct at least two a comma b such that a is less than equal to b and a cube plus b cube is equal to x. So here, like we have this 1729, we have two numbers fulfilling this condition, right? And for 4104 we also have two numbers fulfilling this condition. So the main thing in this problem were the constraints. We are given n is less than equal to 1en, which means if we let's say had to iterate on all, how do I say this? Yeah, we are given n is less than equal to 1en, but the thing is we have to iterate on cubes, right? And if I were to iterate on a single cube, let's say if I were to iterate on all a's, it would be, I would iterate like something like a into a is less than equal to n, right? Which means a is less than equal to n cube, which would mean a is less than equal to 1e3. And similarly, I could iterate on some b greater than equal to a following this rule as well. And then my idea is, in a map, this is not a, assume this is a map. This is, since our values can be very large, we have to use a map here, right? In the map, I would basically, I would run a loop like this, and I would increment every x is equal to a cube plus b cube, right? And this, since this is constant for all the values, this can be pre-computed for our max n, and then I could just, for every test case n, I would just iterate on all values less than equal to n, and if frequency is greater than equal to 2, which means it was hit by more than 2 such pairs, I will increment, append it to the answer. So here, if our frequency thing is empty, I run a pre-compute, and the pre-compute was simple. This is a and this is b. J is, I is a and j is b. So for all a cube less than equal to max n, and for all j greater than a and j cube plus a cube less than equal to max n, I am finding x, and I am doing frequency x plus plus. Like I recommend against using pao I comma 3, because this results in, like, it can cause some floating point errors. Yeah, so this was my solution. The complexity would be And this would work since this is 1e3 into 1e3, right, which is 1e6. So 1e6 for the pre-compute, and then 1e6 into log 1e6, which will still work obviously for the pre-compute, and then O of, and then I'm iterating on every value in the map, right? So that would depend on the number of values, but this obviously this won't be less greater than 1e6 since we have at most 1e6 distinct values. So yeah, this was my solution. Q3 was really interesting. My solution is very jank, but I had to like debug and solve it, which is why. Alright. So basically Q4 is we are given an array and a special index is an index which is greater than its neighbors. Right, this would be special, let's say 5, 9 and 6. This is special since it is strictly greater than its previous and less next element, right? And since special is defined for only 1 to n minus 2. What we have to do is we have to maximize the number of special indices and we have to minimize the total operations to achieve that maximum. So my first observation, which was correct, was that when the array is odd, the special indices are fixed. Like let's say, and the size of the array is, this is 8, but let's make it 9. And the size of the array is odd. We only have one possible arrangement for special indices, which is it has to be here, 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 and here, right? 4. And this special count can be given by n minus 2 ceil div of n minus 2 by 2. Which is basically n minus 2 plus 1 by 2, so n minus 1 by 2. This will for even or not, this will give us the correct thing. But if we see for an even length array, okay, yeah, this is 8, okay. Here also the number of special indices here are 3. We can't make more than 3 because it could be this, and this. This can't be special, right? The edges can't be special, or it could be this, or I'll make it some other color. It could be this, or this. So this was my initial idea basically. For odd, so I can simply calculate, like it's just iterating, checking the max from left and right and doing some math operation. That wouldn't take a while. But for even, because of this issue, I was like, okay, I'll start from this index one time and I'll start from this index one time. Then I'll have 2 answers and then I'll minimize. But the issue is, this is not necessarily the only 2 cases. We can also have a case like this. We have this, and we have this, and so on. There can be like multiple such cases. Like with this arrangement, like you take one, then you skip one, you take one, then you could skip 2, and so on. So after my wrong answers, I realized that okay, this idea is not generic at all. I'll have to make some modifications. So my idea was, my final idea was basically for the same thing. For odd case, the answer would be, you understood why only one possible answer is there, right? For even case, what I'm doing is, I'm doing there are 4 cases from what I understood. Either this is 0, this is 1, this is n minus 1, and this is n minus 2. Either I'm starting from here, and I'm on this side I'm starting from here as well, which would mean I take this, I take this, and I take this, and I take this, right? This is the odd concept. Okay, this is an odd case. Now I'll have to. This is n minus 3, this is n minus 2, this is n minus 1. Alright. This is very easy. Okay, so my idea was either I start from this and this, which would mean that I'm marking this, and this, which is this is 4 would be our max here, right? Since this is n is 10, so we have 10 minus 2, which is 8, and it's of ceil division by 2, which is 4. So this is one possible arrangement, and the other possible arrangement here is, instead of starting from here, I'll start from here. Or I could also start from here, but then if I start from here, this is not possible, right? Two adjacent peaks are not possible. So to simplify all of these cases into one, what I did was I am maintaining a prefix and a suffix count. Assume like for the current state, I am starting from here and I am starting from n minus 2 here. So for in the prefix thing, I am checking what are the number of peaks I have created and what is their cost. Similarly for the suffix thing, I am also doing this. What are the number of peaks and what is the cost. Now assume at some index I, some generic index I. If I am trying to make this a peak, the next peak is either at index I plus 2 or I plus 3, right? Any greater, and then we would be minimizing the number of peaks. You can try this out with some dry runs. This was my observation. So either the next peak is at I plus 2 or I plus 3. What I would do is, since I have my prefix count here and I have my suffix count here as well, what I can do is I can first, using the suffix counts, which is the number of peaks created in both of these directions, I can first verify if the total number of peaks is equal to our required amount, which is n plus 2, oh my god, n minus 2 plus 1 by 2, right? This is the CL division of n minus 2 by 2. If this is true, then I'm also maintaining the cost up till here and up till here, so I minimize this inverse. And similarly, this is when I'm starting from here. But there is also possible that and also a case is possible where instead of starting from here, this is the bad thing. Instead of starting from here, I start from here, and from here I start from here. So basically, on all of these 4 cases, I am enumerating them, doing the suffix and prefixing, and minimizing the answer. I think my code will make it a bit more clear. So like for the odd case, the answer is trivial, right? It's just this. We start from 1, the left starts from 1, and the right starts from n minus 1, 2. And we minimize the answer across this. But for the other cases, I am enumerating all the 4 options. Start from 1 and end at n minus 2, start from 1 and end at n minus 3, start from 2 and this, and then across all 4 I am taking the minimum and I am returning the answer. Now how my computation here is, first of all I am calculating the required number, and this is the prefix cost, prefix count, suffix cost, suffix count, right? Here if I am starting at L, that would mean I am only performing the operation when my parity is same, right? Like here, if I start at here, then I am performing the operation here, 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 and so on, right? Similarly, if I start at here and perform the operation at here, so basically the parity has to be same for the operation. So in that case, I am doing the operation which is taking the max from both ends, finding the cost, assigning it to the current, and then obviously the current cost as the count. And here this is the prefix sum. Similarly for the opposite direction, since I am starting from the right at R, I have to ensure that my parity is same there. The same thing here, just for suffix and then suffix sum. Now here this is how I am minimizing. I initialize it to infinity. Now for every I, let's say somehow, like for the odd cases, like for the odd length case, it would also be possible that just a single point can fulfill our answer, right? Like let's say, too many arrays I have put now. This is an odd case. Like when we reach here, the count will be 3, right? Because it will take this, this, and this. So, and here the required amount is also 3. So here we can just minimize using a single value. If my prefix count of I is equal to required, then you can just minimize using that. Else I'm doing this, my j, the next is either I plus 2 or I plus 3, and if it is within the range, then I'm just doing this. Prefix count I plus suffix count j should be equal to my required, and then I'm minimizing with respect to the values. Now similarly, I'm doing the same thing just for when I'm making I the suffix. Here I is my main controller. The same single check. This one is not required, but still. Now j can be either I minus 2 or I minus 3, and then the same thing. Obviously, I'm sure there is a more optimal solution, but this is what I did during the contest, like 4 wrong answers. So this is what happens after 4 wrong answers. You just get desperate for a solution, but yeah. So this was Q3. I really liked Q3. Q4 was on the easier end. I'll show the solution I submitted during the contest, then I just spoilers here, but yeah, whatever. So it was another similar idea. We had to deal with peaks, but here the array is circular. So right, for this can also be a peak if this is greater than this can be a peak if this is greater than this and this, right, since it's circular. and here we have to find the minimum cost, and the operation is again the same. We have to increment the value by 1. We have to find the minimum cost so that the array contains at least x peaks, and if it's not possible, return -1. Here the first thing was the constraint says less than equal to 5k. That means n into k can work. N into k can work, and then I was like, okay, maybe some sort of DP idea here will work, and my initial DP idea didn't work, but after some observations, yeah. Basically, assume we are given an array. My intuition was at some arbitrary index, either we make it a peak or we don't make it a peak, right? If we make I a peak, then the thing then the thing is we can't make this a peak, right? We have to go to I plus 2 or there, but the number of peaks would get reduced, right? So at I comma k, where k is the number of peaks required and I is the index, we can if we make this a peak, and the peak making operation is the same. We look at left and right, and if it's the first, we check the circularity, and then we do the cost, and then we iterate to I plus 2 comma k minus 1, since 1 less peak is required, right? And if we don't make it this a peak, we can simply transition to I plus 1 comma k. So this was the first transition, but here there can be an issue, like assume for some array we made this a peak, and now we are trying to make it a peak with respect to the last element as well, right? Which is why this test case was helpful. So if you look at this 373, here let's say we try to make this a peak, so we'll make this 8, right? We add 5, we go to this, we can't make this a peak since we make this a peak. And here what will happen is, since our current iteration does not know that we made this a peak as well, we will try making this a peak, so we'll make this 8 as well, which will incur a cost of 5, which will make the total answer as 10. But obviously this is not possible, 2 peaks here are not possible only. So because of this circularity, what we have to do is, we also, like what I did was, I also maintained if I made the first element a peak as a separate state, and I pass that into the array, and basically like if I reach the last, and the first element was also basically, I'm trying to make the last element into a peak, and the first element was also made a peak, which is a state, a boolean state 0 or 1, then I won't make this a peak, right? So yeah, this was my idea. This is just me setting the DP thing to -1 manually, and then at every I, if I is greater than or equal to n, which means our index exceeded, either we return k, if k is 0, that means we have made all our elements peak, right? Then we return 0, and if k is not 0, that means we couldn't reach our goal of making at least k peaks. So in that case, we return a very large value. This is the memorization k. First peak is basically if we made the first element a peak or not, which is just a boolean state. I is the index and k is the number of peaks remaining, right? So here for ease, I am getting the left and right circularly, the left and right indices. For not peak, as I stated, we just transition to I plus 1 and k, and this thing remains the same. And for peak, if the current index is the last one and we made the first element a peak, that means we cannot make this a peak, right? This can't be set as a peak, sadly. This is can't. Else, otherwise, we can always try making this a peak. And for making this a peak, this is our current cost. The next peak would be either if the next first peak would be if the first was already the peak, or we are making the first a peak, right? So this is sort of a digit DP transition, and we can set the cost here. And then this is just res min of peak, not peak, and then we minimize it. So yeah, this was my solution. Overall, a cool problem, cool contest. I think my rank already, yeah, whatever. So I'll be attaching my live solve section after this, and let me know if you have any doubts. Alright, bye. अबे यार